We will present our paper using open source software QucsStudio to design a microwave amplifier for SDR applications. Javier, Rivera, and Javier Mendoza. Introduction. Nowadays, open source software has emerged in our lifetime to develop any applications in the industry, education, and the research field. That is the case of the software QucsStudio, a versatile circuit simulator that can help us to design and simulate high-frequency circuits with excellent performance in different projects. Justification. Today, microwave technology are more pervasive than ever, where modern applications include high-frequency design. Hence, microwave computer-aided design, software, and network analyzer are essential for today's microwave engineering education. We are proposing this software to make many projects in microwave application. This proposed method is an alternative that universities can use with no access to RF or microwave application licensed software. QucsStudio let us develop challenging projects at high frequencies. Abstract. This work presents the analysis and design of a microwave amplifier for SDR applications to have a maximum transducer gain by applying distributed matching elements at 1.9 GHz. The proposed design achieves 10.4 dB at gain at 1.9 GHz with a frequency response from 1.06 GHz to 1.96 GHz with 10 dB of attenuation. In this picture, we show the range frequency of the HAC RF SDR module and the amplifier we have designed it and the receiver. And the transmitter have 6 GHz of range and the receptor only 1.7 GHz. This is the difference and limitations we have in these measurements. Now we are going to explain the amplifier design very briefly.
Hello, Jose and everybody. I will continue with this presentation. Okay. We can see in this picture in the left side that we did using this software QucsStudio. So first of all, we did a DC bias circuit in order to model the transistor. Okay. In this case, for this project, we used the heterojunction bipolar transistor. How we designed this DC bias circuit using the S parameter that the manufacturer gave us as a S parameter file. So in this case, in the left side, we show the DC bias circuit that we use for this amplifier design. And as we can see below, on the Smith chart, we can see that both input and output impedance are mismatched. So what is the task in this project is to design this amplifier using the distribute elements. So for this goal of this project, we designed this input and matching network in order to match this amplifier. In the right side, we can see the full design of this microwave amplifier, and also we can see below the Smith chart picture, and it gives us the correct matching network. So for this case, we implement this project in a commercial substrate. For this case, we use this characterization of the substrate, the thickness, the relative permittivity, the loss tangent, and the metal thickness. Okay. In order to test the performance of this amplifier, we did the application using this software-defined radio. In this case, regarding to the implementation, we choose 1.5 gigahertz frequency design. And why it was different with the frequency of the amplifier? Because the receiver device, the RTL SDR, is limited in the frequency. In this case, it's just for 1.7 gigahertz. That was the reason that we use the carrier frequency for this amplitude modulation at 1.5 gigahertz. Well, in this picture, we can see the characterization of this amplifier. As we can see, we did this characterization using the vector network analyzer, and here we can see the results regarding the gain and also the reflection coefficient to the input and output. As we can see here, there is a little bit difference between the measurement and the simulation. For this case, at 1.9 gigahertz for the frequency design of the amplifier, we got 10.4 dB of gain in a real scenario measurement with a VNA. Okay. Well, here we can see the lab, the test lab. Using the SDR, the amplifier, this antenna, and a small connector. And we can see here in the right side the reception at 1.5 gigahertz. This is the spectrum. And below, there are the results about the power that transmit the transmitter. Using the amplifier and without using the amplifier. So we can see from this picture that the gain is about 10.5 dB. There is a little bit difference here because using the VNA characterization of this amplifier, we got 12.4 dB of gain. But what happened here, most probable that there is losing power using this connector, using this connector because it's affected to the real measurement. Okay, finally, the aim of this work was to analyze and design this microwave amplifier using this open source software that can be used at any university that they don't can access to this licensed software. And to prove this performance of this amplifier, we developed a software-defined radio application. The frequency design was different because all those SDR device was limited in the frequency. Yeah? And finally, the biggest, this project was like a proof, an alternative method that universities, most in Latin America can be used, this kind of software because it's open source and the environment that present is almost similar like maybe ADS. And we can use it without any complication because this is the biggest challenge, this project. Finally, we conclude with this presentation, and I'm sorry for this first presentation. Okay, now we are open for some questions, if maybe someone.
Okay, Javier, thank you very much. These things happens. This virtuality has these disadvantages. The advantage is that at least we can share our works worldwide just from our computer, but the disadvantage are that sometimes this is not so smoothly. So don't worry, it was very clear, and thank you very much for your work and for your presentation. I see that there are no questions at this time. So we are closing this track at this moment. I hope to see you all again in the next track that will begin at 2 p.m. Uruguay time. It's in 30 minutes or something like that. So thank you very much for all the presenters and for all the assistants, and hope to see you soon.
Thank you very much to you, Jose.